Welcome to the Wonderful Seagulls Podcast, where we explore the loud, clever, chaotic world of urban gulls. Before we dive into today's gull story, please like this video and subscribe to the channel so you don't miss more urban wildlife, gull behavior, and neighborhood drama. You know, Sam, it is so easy to walk past a gull on the street and unfairly dismiss them as just another trash bird. But today, we are looking at something that completely blew my mind.
Oh, absolutely, Alex. We're looking past those old stereotypes to reveal gulls for what they truly are, absolute evolutionary marvels. By comparing their internal biology, specifically their incredible immune systems, directly to our own, you realize they aren't just surviving in our cities. They are biological masterpieces built for resilience.
To really understand just how incredible they are, Alex, we have to rewind the clock back about 300 million years. That's when the mammalian lineage, which eventually led to us humans, and the avian lineage split.
Right, and both of our branches face the exact same survival challenges on Earth. We both had to fight off infections, remember pathogens to build immunity, and manage our energy perfectly. But because we split 300 million years ago, birds and mammals developed radically different physiological solutions to those identical problems. It's like two different brilliant engineers solving the exact same puzzle in completely opposite ways.
Here is our roadmap for today, as we follow a gull's incredible life cycle. First, the evolutionary split. Second, the bursa of Fabricius. Third, immunity inside the egg. Fourth, seeding the pioneer microbiome. Fifth, regurgitation as breast milk. And finally, sentinels of ecosystem health. Section 1. The evolutionary split. Radically different architectures. Think about your own body for a second. If you get sick, you probably feel your lymph nodes swell up, right? And your immune cells are constantly being generated in your bone marrow throughout your entire life. But gulls, they don't even have lymph nodes, Sam, and instead of relying on bone marrow to continuously pump out these specialized immune cells, they use an entirely different setup, which includes specialized immune cells called non-oxidative heterophils. The really fascinating part, though, is where their immune system actually originates. Section 2. The bursa of Fabricius, a transient B-cell factory. The bursa of Fabricius is a specialized, temporary organ located near the bird's cloaca. Now, what's genuinely amazing here is the timing. Yeah, because humans generate our antibody-producing B-cells continuously, day after day, for our whole lives. But a gull operates on a totally different schedule. They generate their entire lifetime supply of these vital immune cells in this one temporary organ during just the first 6 weeks of their life. It's an intense, rapid-fire biological factory. They use a process called somatic gene conversion to build all the genetic variety they will ever need to fight diseases. And then, by the time the gull reaches sexual maturity at 6 months old, the bursa just safely shrinks away and disappears. Its job is completely done. Because they don't have that vast network of lymph nodes like we do, they had to put their defenses where it matters most. Over 70% of a gull's immune system is actually gut-associated lymphoid tissue. It's essentially an ironclad digestive tract. And when you think about how clever and adaptable gulls are, Alex, foraging along beaches, exploring urban environments, trying a huge variety of foods, having 70% of their immune defenses concentrated right in their gut is absolutely perfectly adapted for their opportunistic scavenging lifestyle.
Section 3. Immunity inside the egg, the prenatal defense.
This is where their biology gets incredibly elegant. Human mothers can continuously pass antibodies to their baby dynamically through the placenta. But a mother gull has a unique challenge, the egg. Right. Once that egg is laid, the physical connection is severed. So the mother gull has to brilliantly pack a finite, perfectly portioned immune care package right into specific compartments of the egg during assembly. It's an astonishing bit of biological packing. And it happens in 3 distinct steps. First, the mother actively transports systemic antibodies, called IgY, directly into the nutrient-rich yolk, which goes straight into the chick's bloodstream as it grows. Then, step 2, she secretes completely different mucosal antibodies, IgA and IgM, into the egg white, or albumin. Because there's no blood connection to the egg white, those antibodies just sit there in the fluid. Until step 3, right before hatching, the developing embryo literally swallows that surrounding fluid. It drinks down those antibodies, perfectly pre-coating its tiny digestive tract with its mother's immunity before it ever faces the outside world.
Section 4. Seeding the pioneer microbiome, the first microbial exposures.
That pre-coating is vital, Sam. But maternal antibodies alone aren't quite enough. To truly thrive, the new chick needs to establish its pioneer microbiome, the very first good bacteria that will inhabit its gut. In mammals, this crucial first exposure usually happens during birth. Passing through the vaginal canal provides a baby with its first critical microbes. Obviously, gulls hatch from eggs, so how do they get that initial healthy bacterial boost? Well, they get it from the shell itself. When the mother lays the egg, it gets coated in a specialized, beneficial maternal biofilm. Breaking through that eggshell serves the exact same evolutionary purpose for a gull chick as passing through the birth canal does for a mammal. The act of the chick pipping, which is when it uses its beak to physically break and push through the shell, forces it to interact with and swallow that maternal biofilm. And this isn't just an accident, Alex. It's a deeply evolved transfer of life. Swallowing those specific microbes initiates a rapid colonization of the chick's gastrointestinal tract, which literally jumpstarts the development of its immune organs. Studies even show that gull hatchlings who get this specific early microbiome actually have better cellular health and larger telomeres.
Section 5. Regurgitation is breast milk. Postnatal behavioral support. Okay, so the chick has hatched and got its pioneer microbes, but the immune journey doesn't stop there. After hatching, stabilizing this gut microbiome requires continuous, dedicated behavioral support from the incredibly attentive gull parents. In human biology, we stabilize a baby's microbiome largely through breast milk, which is full of specialized sugars designed purely to feed good gut bacteria. Gulls do something structurally similar, even if it looks a bit different to us: beak-to-beak regurgitation. The parent gull forages, stores the food in a specialized pouch called a crop, and then returns to gently regurgitate this semi-digested food directly into the eagerly waiting chick's mouth. I know to human sensibilities, regurgitation might sound a little messy, but biologically, it is an absolute masterpiece of parental care. This food is totally saturated with the parent's beneficial crop microbiota and protective enzymes. This beak-to-beak physical contact is essential for a process called competitive exclusion. The parents are densely packing the chick's gut with their own beneficial bacteria. Because all those good microbes take up the physical space along the intestinal walls, any harmful environmental pathogens the chick might ingest simply have nowhere to attach.
Section 6. Sentinels of Ecosystem Health, the Iron Gut.
So, moving into adulthood, with their microbiome fully established through all this incredible parental investment, just how strong is this highly adapted defense system against real-world pathogens? It is remarkably strong, Sam. Thanks to that robust mucosal immunity we discussed earlier, adult gulls can easily tolerate and carry bacteria that would be highly dangerous to us, like Salmonella and Campylobacter, without getting sick at all. It really highlights their incredible resilience. However, they aren't invincible. While they handle bacterial pathogens beautifully, they are highly vulnerable to neurotoxins, specifically those produced by Clostridium botulinum, which can cause severe paralysis and massive die-offs in wild populations during periods of ecological stress.
But returning to their bacterial resilience, there's one more genetic trick up their sleeve that I find absolutely fascinating. Gulls completely lack something called the TTP gene. In mammals, this gene helps regulate inflammation. Because gulls are missing it, they operate on a fundamentally different inflammatory regulation scheme. This incredible adaptation prevents them from suffering lethal systemic inflammatory cascades when they encounter massive bacterial loads. It's essentially the genetic superpower that allows them to forage safely and opportunistically anywhere from a pristine beach to a bustling urban center.
And this brings us to a really vital point about their role in our world. Because they are so resilient, occupy a high position in the food chain, and forage so widely, the Lauridae family, the gulls, function as key environmental sentinels for public health. Tracking the health of wild gulls gives us a remarkably sensitive barometer for our own ecosystem stability. When they're carrying multi-drug-resistant bacteria, it's usually because they picked it up from human agricultural or urban runoff. They are reflecting our environment right back at us. Which leaves us with this final, really important question to ponder. If these magnificent birds, who have spent 300 million years evolving an ironclad masterpiece of an immune system, are suddenly suffering from massive botulism outbreaks due to environmental degradation, what hidden toxins are lurking in our own shared ecosystems? Thanks for watching. If you enjoyed this episode, please like the video and subscribe for more gull stories, urban wildlife, and the ongoing adventures of gulls.